All right, everyone. So in this video, we are going to talk about the first skill in Unit 5, which is called collision theory. And in this, we talked about, the theory of collisions and the collisions between molecules. Now, in order for molecules to react, they actually have to collide and hit each other. And we refer to certain collisions as being effective and other collisions as being ineffective. An effective collision occurs when two reactant molecules collide with each other with enough energy and the correct orientation. Now, when you're thinking about orientation, another way to think about it is rotation. Okay, the molecules have to be rotated a particular way so that very specific atoms are the ones that hit each other. Now, when we're talking about having enough energy, okay, the energy that is required to create an effective collision is called the activation energy. It's the energy required to activate or get the reaction started. And you can measure the activation energy by subtracting the total energy of the graph, which if you're looking at a reaction diagram, that's the high point on the graph, minus the energy of the reactants, which is where you start out at. So that would be right here. That's your activation energy, which we talked about that in the videos in Unit 4 about endo and exothermic. So in this case, we'll look at that later. But when molecules collide, there is a possibility of a bond forming between the atoms that hit each other. So you have to think about, okay, where do I want a new bond created? Which atoms need to be involved? And the molecules must collide so that the correct atoms hit each other to form the product. Now, when we look at question 1, and I'm sorry, if you can hear me like sniffing and stuff, I think I might have a cold coming on. But according to the graph on the right, how much energy is required to make an effective collision? Well, the energy required, they're asking you for your activation energy. How much is it? What do we need? So if we look, our activation energy is the top of the hill, which according to our graph is about 18 kilojoules, minus the energy of our reactants, which is right here, and that's 10. So our activation energy is 18 kilojoules minus 10 kilojoules, which equals 8 kilojoules. In Genesis, if you're watching this video, I would like to point out that this time I subtracted correctly. If you watched my endo and exothermic video, you might have noticed that I did not calculate it correctly there. Well, I wrote it correctly and then did the mental math wrong in my head. But I'd like to point out that even though I made a mistake, I showed my work, so you knew exactly what I did and how I got that mistake. So that means when things collide, if they don't have at least 8 kilojoules, the reaction can't happen. It's like trying to go to the store and buy something that has $8, but you only have $2. That's not enough. You don't get that to happen. And so if a collision happened between the molecules below to create the product mentioned with 5 kilojoules of energy, based on the reaction diagram above, would the collision be considered effective? Why or why not? So when you're deciding if a collision will be effective, you have to check 2 things. And one thing that I saw in your Unit 5 test is a lot of people only looked at activation energy. You have to check 2 things. You have to check your energy and whether or not it's enough, and you have to check your orientation. Okay, so if we look here, let's check our energy. They're telling us that when they collide with 5 kilojoules of energy. Well, our activation energy is 8. So if I show up to the store with only $5 and the thing I want to buy is $8, this will not work. So that means this collision won't happen. That is not enough. But just to look at other things, we want to look at the orientation. If this is the product we want to form, if we look at this right here, the only thing that's missing is it needs another purple atom next to the green one. So we see if the green and the purple collide, that there will be a bond formed there, and that is the correct orientation. So when we put this into a sentence, okay, we know that even though, so we can start out that way, even though there is the correct orientation, which I'm just saying, telling me that and telling me that you know that is really good for your grade and getting full credit. So even though there is the correct orientation, the collision only has 5 kilojoules and 8 kilojoules is needed. So this is not effective. Okay, so that's kind of, you can word it a lot of different ways, but that is one of them. So now if we move into section 2, which is really, really small, it's just information about catalyst. So a catalyst speeds up a chemical reaction by changing the orientation of the molecules. It basically rotates them so that they're oriented correctly. And by changing that, it actually lowers the activation energy required to get the reaction started. And so catalysts, they're not changed by the reaction, they're present and they change the reaction themselves, but they stay the same. And they can be used to decrease the amount of time that it takes for a reaction to run. So this is because, like, let's say we're looking at a reaction diagram that looks like this, okay? And pretend this is you. This is, you have green hair, okay? And you're running a race, and this is the finish line down here. Well, in order to get to this finish line, you have to run all the way up this hill to get there. Okay, well, what if instead of running up that hill, what if you had something that lowered your activation energy or the path it takes by making sure you're correct? Well, then if you only have to run up this short hill, that will take less time. And that's what a catalyst does, is this graph right here would be with a catalyst, and this one would be without a catalyst, kind of normal. Not having a catalyst doesn't necessarily slow it down because that's just how it is naturally. But when you do have a catalyst, it speeds up your just normal pace. And so that is what a catalyst does. And so it's kind of connected with this collision theory because it rotates them correctly. It makes them easier to collide correctly. So that is the first video for Unit 5. And then in our next video, we'll finish up with the math part of Unit 5 as we look at the gas laws.